All right, class, today our lesson is going to be about factoring and trigonometric functions. We're going to be able to factor trig functions using factoring patterns and use factoring in proofs, although we probably won't get to proofs today. Let's take a couple minutes and just review factoring. Remember, whenever you see four terms, you want to factor by grouping. So for example, if I had x to the third plus 2x squared plus x plus 2, since I have four terms, I would group the first two and group the second two and pull out anything that they have in common. When you see three terms, maybe you're in a situation like this, x squared plus 2x plus 1. Again, you want to think of factors of 1 that add up to give you 2 and make your factors from there. And then a greatest common factor, remember, each term has the same number in common. So perhaps I have y times x plus y squared. Well, both terms have a y, which means that I can factor out the y. And then we have our special factoring patterns. Our first one is the difference of squares. That's when we have a perfect square subtracted by a perfect square. And it factors according to this pattern. Remember, your middle term is 0. So technically when you multiply this out, your a times b term is going to cancel out. It does that because you have the a here, and the a here, and the negative, and the opposite signs, and then the b. So to get these numbers, you just square root both the first and second term of your original polynomial. Remember, your sum and difference of cube factoring patterns are basically the same factoring pattern. You just have to remember how the positives and negatives relate. To get to these numbers, you first have to cube root a cubed and b cubed to get a and b. Remember, these signs are always the same. These signs here are always opposite. And the last sign is always positive. And the second set of parentheses is made up of a squared in the beginning, b squared at the end, and you multiply a and b in the middle. I know we've talked about these a lot, but it is good for us to review these things. Now, since we're studying trigonometry, we're going to end up factoring several different types of trig equations. So it's important that we practice just simply factoring. So for this first problem, I'm going to change this to a minus, so it works out right. I have the sine squared x plus 2 sine of x minus 3. And it's kind of hard for me to think about that right now. Maybe if I dropped the signs at first and just thought about it as x squared plus 2x minus 3. I want to think of factors of negative 3, that when I add them, I get 2. And again, I could make my factor tree. The only factors of 3 are 3 and 1. To get a positive 2, I would have to have a negative 1. Since the leading coefficient of this polynomial is 1, the first term of both parentheses are going to be x. And then I have the plus 3 and the minus 1. We can apply the same concept to the trig equation. So again, I want to think of factors of negative 3 that add up to give me 2. The factors of negative 3 that add up to give you 2 are positive 3 and negative 1. Now for this first number. Since we have this term being a sine squared, the first number in each situation is going to be a sine of x. And just to prove that I'm correct, I'll go ahead and distribute this out. When you factor on your own, you don't necessarily have to do that. But sine times sine is sine squared. Sine of x times 3 is 3 times the sine of x. Negative 1 times the sine of x is the negative sine of x. And negative 1 times 3 is negative 3. Combine the terms. And I've checked myself. I did factor this correctly. Let's try another one. 1 minus the cosine squared of x. At first glance, this might seem like it doesn't factor because there's only two terms. But remember, if I think of it as 1 minus x squared, just an x, this is the difference of squares. 1 is a perfect square, and x squared is a perfect square, which means it automatically can factor. The square root of 1 is just 1. The square root of x squared is just x, and I know I have to have opposite signs. The same concept can be applied here. I have two terms, so I break apart to two parentheses. It's the difference of squares because cosine squared is a perfect square. I've got 1 and 1. I know I will have opposite signs, and to get cosine squared, I have to have a cosine in both positions. It is important with this that you write the 1 first because you need the cosine term to be negative. Now for this one, looking at this one, I only have two terms, but a special factoring pattern really doesn't jump out at me right away. Since I notice that both terms have a secant, I'm going to pull that secant out. Now what am I going to be left with? If I take a secant out of this first term, then I'm just left with 1. And if I take a secant out of the second term, then I'm left with just the tangent. 1 minus the tangent of x. There is no more factoring that I can do with that situation, so I'm done with this problem. Now let's consider this one. I have the difference of cubes here, because secant cubed is a perfect cube, and sine cubed is a perfect cube, which means that my a term had to start out as the secant of x, and my b term had to start out as the sine of x. Because I know my special factoring patterns, I can jump straight here. I know the first sign is going to be the same, the second sign is going to be opposite, and the last one is always positive. Now I just have to fill in the blanks. A minus b, so the secant of x minus the sine of x. Then a squared, so secant squared. Then a times b, so secant of x, sine of x. You could have also written it the other way. And then the sine squared of x. Just as a review, it's a minus b, and then a squared plus a times b plus b squared. It's nice to see that the factoring rules apply to all of our special situations. And this will be our final factoring problem. I've got the cosecant of x minus the cosecant squared of x, plus the cosecant of x minus 1. Sorry, cosecant cubed of x to begin with. Since I see four terms, I automatically want to think factoring by grouping. Now, from here, it's just pulling out greatest common factor. So the greatest common factor between the first two terms here would be just the cosecant squared of x, because there's 3 there and 2 there. In the parentheses, I write what's left. So it's the cosecant of x minus 1. I need that placeholder there. And then for the second set of parentheses, I don't really have anything in common, so I say that I pull out a positive 1. And I have the cosecant of x minus 1. Since I have two sets of the cosecant of x minus 1, I can pull those out as one set. From here, I should really check to make sure that I don't have any more special factoring patterns. Just the cosecant of x minus 1, and then the cosecant squared of x plus 1. That's not the difference of squares, so I can't factor that. So this would be my final answer. I'm completely factored. All of the factoring rules that we've learned can apply to trig functions, so it's important that we practice using them with trig functions so we get used to it.